Now we are slightly familiar with these graphs. So initially you have to know something. So I'll use two different equations to explain the type of graphs we are having in those cases. So first equation of the quadratic function would be if like the positive or negative. There are two possibilities. That is the positive, its nature and their corresponding components are different. If it is negative also, it is slightly different. Let's draw a table to understand that one. Now let's have a look into it. The graph of function of positive or negative x plus b whole square plus c. So when we know that if the x is having a square value, the x is having a square value, that means it should be a quadratic function. In those cases, we can obtain either this kind of parabola, okay, negative parabola or positive parabola. These are the only two type of graph we can draw by using quadratic function. Now let's come to these two instances. Look at here. Here when you expand this expression, the coefficient of x would be positive. Coefficient of x would be positive. Look at this. There is no any direction before it. Now when you expand this, x square plus 2bx plus b square plus c. Coefficient of x square is positive. Coefficient of x square is positive in these cases. In those cases, if the coefficient of x square is positive in a quadratic function, that curvature would be a minimum graph. The coefficient is a positive value, no problem. It is positive 1, positive 0, positive 0.1, positive half, positive 100, positive 1000, no problem. If it is a positive value, this graph should be a minimum graph. Minimum graph means decreasing parabola. Okay, like this. This would be the shape of the graph. Now let's come to the next one. When you expand the second expression, look at this. It is having a negative common factor. Inside it, we are having a quadratic expansion. So after that quadratic expansion, we will have a negative coefficient for x. Look at this. It is having a negative. Thereafter, x square plus 2bx plus b square. Likewise, you can write and expand that with the negative common factor. It will give you the common factor as coefficient of x square as a negative value. Coefficient of a x square as a negative value. In those cases, we can obtain a maximum graph. This is the nature of the graph, maximum graph. In here, the graph shape would be like this. Shape of the graph would be like the coefficient is positive, minimum curvature. If the coefficient is a negative value, it should be a maximum graph. Next, maximum and minimum value of the function. How to find that one? Maximum value, minimum value means when you draw a curve like this is the minimum value. Okay, it's corresponding y value. This is the minimum value. By in this type of graphs, when you make your graph equation into this type, in those cases, minimum in minimum occurrence, the minimum point would be y equals to c. When y equals to c only, we can have the minimum point of that particular curve. We are used b and c as some identification value. In actual example, I will use some numbers to explain. So what is this? When you draw your curve, what is the minimum point? Its corresponding y coordinate is called as minimum value of the function. It would be c. Okay, this c and this c both are same. In the next type, when the coefficient is negative, like this, negative x plus b whole square plus c, those kind of graphs, when your graph equation can be arranged like this, in this manner, you can have your graph as a positive graph. In those graphs, I'll take like this. This is your graph shape. So maximum value of the function would be its turning points y coordinate. Okay, turning points y coordinate. So it should be like this. Okay, like this. So this is the point. In these kind of graphs also, y equals to c. Look at this. When you make your graph equation like this manner, in this manner, you can easily identify. Not by not drawing the graph even, you can find whether what is the nature of the parabola, minimum or maximum. What would be the minimum or maximum point of the function? Not only that, you can find the coordinates of minimum or maximum point as well. We will find that one as well. Coordinate of the minimum or maximum point, it is also really simple. How to find that one means coordinate. Here you are having x plus b whole square. You need to find this value is negative. X plus a particular number. For an example, x plus 1 whole square means the coordinate would be negative of that one comma c. Negative of that particular function square comma c. Look at this here. Inside the x plus particular value square, you are having its positive value. But while you are writing that as a coordinate, it should be negative of the square function. Okay, negative value of that square function plus comma c. Comma c. Either c can be positive or negative. It doesn't matter. But here, if you have a number, you have to make it opposite as its direction while writing the coordinate. For the next one also same. No need to worry about this negative. When you expand this one, look at this x plus b whole square. It is having a positive value inside the bracket of square value. So in coordinates of maximum or minimum point, in second occurrence, we are having a maximum graph. So coordinate of the maximum point would be negative b. Negative of the square number square. Inside the square, you are having a numerical value. I am talking about that square number. It's negative and comma c. This would be the turning points coordinate. This would be the turning points coordinate. And one more thing, equation of axis of symmetry, it could be x equals to negative b. Okay, x equals to negative b. Look at this. When your curve is like this, when you draw the equation of symmetry, it is going through the turning point. Okay, it is going through the turning point. So x is equals to negative b. That would be the equation of the axis. For the next one also, equation of the axis. This is the positive one for here, negative one for the next one. Get here. This is also going through the minimum point. Its corresponding x coordinate. So it would be x equals to minus b. This is just a graph and theory part. So you have to understand these stuff clearly. We can easily apply this into the question as well. I'll use some example questions to explain this one as well. But try to remember these things. Nature of the parabola, minimum or maximum value of the function, how to find, and coordinate and equation of axis of symmetry, how to find that one. That's really important. So now let's use an example. Y equals to x plus 1 whole square plus 3. This is the graph equation. This is the way you are having a graph equation. First of all, you have to determine this is a positive parabola or negative parabola. Just think about it. When you expand this function, no need to worry about other values. You have to consider about the coefficient of x. Yeah, it would be a positive value. Okay, when you expand, it will give you a positive value for x. So this would be a minimum parabola. This would be a minimum parabola. That is our first interpretation. Thereafter, for the second one, minimum or maximum value. Here, look at this y equals to c. Y equals to c. We can directly write that one as the minimum or maximum value. Since it is a minimum graph, we can write the minimum value as y minimum. It is equals to 3. Y minimum equals to 3. Look at here. This is minimum graph. So y minimum would be the c value. Here the c is substituted as number 3. So we can directly write it as 3. And in next one, coordinate of turning point. So b, that means inside it is having a positive value. Its opposite direction. Okay, if it is a positive one, its opposite direction. Positive one's opposite direction would be negative 1, comma, this c. C value is already known, that is 3. Negative 1, comma 3. it would be the coordinate of turning point. And last one, axis of symmetry. We can write it as x equals to -1. Okay? If you can write the coordinate correctly, you can easily identify. By using the coordinate, its x value would be the axis of symmetry, its y value would be the minimum or maximum. By if you would be able to write this one properly, by that you can find other two parameters. Axis of symmetry would be the x value and minimum or maximum value would be the y quantity. Likewise, you can find. This is the actual example. In exams, you will have something like that. Sometimes your graph equation will be like this. Y equals to x square plus 3x plus 4. Likewise, you have to factorize this like this square manner. You have to do that factorizing thing. Thereafter only we can apply this theorem. In this format only, you can write your graph equation in this particular two formats only. You can interpret this data like this. If not, there is no any b or c values to correlate with that one. So be clear with that. So in the second example, when you expand this, you will have a negative value for the x square. So it could be a maximum parabola. Could be a maximum parabola like this. Its maximum value y max would be the c, the constant. Since the constant is 1, y maximum would be 1. Thereafter coordinates. Here you have to be careful. If the value is positive, look at x plus b. If it is plus b, you have to write here negative b. If it is negative 2 already, here you need to write positive 2. Okay? The square inside the x plus particular number square, you have to make its opposite direction. Since it is a positive b, we made it as negative b. It is negative 2 already. It should be converted as positive 2, comma 1. C value is 1. And by looking at this coordinate, you can write the axis of symmetry as x equals to 2. X equals to 2 would be the axis of symmetry. Y equals to 1 would be the maximum point. That's all.